This is your prod Cassandra cluster. Let's call it C1. As we see, it has 6 nodes. And as I said, every node is nothing but a self-contained compute storage network entity. It could be a Dell server, IBM server, Supermicro server, doesn't really matter. And let's have our test dev cluster, which in this case, let's call it C2, and it has 4 nodes, right? And as I mentioned earlier, agile application development, this could be either on-prem or in the cloud for really that cloud mobility use case. So, of course, if you're going to think about data management or backups, you have to think about secondary storage, or what we call the backup storage. And today with Datos, we of course support classical NFS for backup storage. And why? Half of our customers are still on-prem, and an on-premise world is not going anywhere, which is why we strongly believe in the world of hybrid cloud. So we support NFS as a target for backup storage. We support S3, which could be either an Amazon or Google Cloud Storage. Today we are certified with both of those public cloud platforms. And then finally also, any class of object storage which comply to the S3 APIs. So, but for on-prem, right? And these are appliances like Cloudian and Scality and CleverSafe, which have really built these large-scale object repositories. So we support all those 3. And final piece of the reference deployment diagram, which we call the third piece, is really the RecoverX software. And as I said, it can be deployed on a VM or a physical server. Any server. We have kept in mind that the CPU memory consumptions have to be the leanest, because we don't want the TCO or the burden of RecoverX to overrun the cost that we're going to save you, right? And third is it, of course, can be deployed in the cloud EC2 instances anywhere. So now we understand the basic sort of reference deployment, Cassandra database, which really we call the data source for people who have experienced firsthand RecoverX, your secondary storage, and your RecoverX piece of software. So RecoverX has 2 components. One is we call these application listeners. These are classically called agents. We deploy application listener on every node of the database. And these are really lightweight. They don't consume any CPU memory, only when they need to be able to wake up and do a backup. RecoverX really sort of talks to your Cassandra database as a control plane. If you remember, I talked about this earlier. We believe the value is in the control plane. And so essentially we have application listeners, which are node agents, and we have RecoverX software, which is where we hold sort of what we call the global metadata catalog. So RecoverX, let's say you have a backup window or your backups that you want to do every hour. So let's just say 11 a.m. to noon and so on and so forth. And really what RecoverX is doing, once you've configured this data source to be managed by RecoverX, and you've configured a data store to be used for backups, we communicate, or Datos communicates with these application listeners to interface with very well-defined APIs of these Cassandra or other NoSQL databases through a API called Node Tool Snapshot. So we're essentially calling a local API called Node Tool Snapshot that essentially is giving us a local copy of all your SS tables. And SS tables really are in the concept or a construct of column families. So every node or every Cassandra database has column families. Column families have tables, and tables have these SS table records. Once we finish this initial operation of grabbing all the local SS tables, the very next thing we do is move this data in as parallel and streaming fashion from every node. I always get this question, hey, do you just move from one node, or the 2 nodes, or quorum nodes, or all? We move it from all. And the whole notion is you need to get that global context of the data to be able to then drive consistency and deduplication. And then that really is what Datos does when the data lands in the backup storage. So we land this data as part of a backup process, and let's just term the landing of the tables as small little triangles, and really Datos then processes them processes them for a very simple notion. A, we want to return a consistent backup, and number 2, we want to reduce these 3 copies because remember, Cassandra, as I said early on, is a scale-out, highly available database, meaning every write is replicated multiple times, usually a replication factor of 3. And so if you have a replication factor of 3, you really have, if you have John lives in San Francisco, that literally is written 3 times, right, across all the nodes. And the whole goal is, can you take those 3 copies and semantically reduce them into one logical copy?